middle of the night by a thud on the hull of our boat. And we rushed up on deck, and we found that we were surrounded by pieces of plastic in the ocean. We were over 1,000 miles from nearest land. In fact, the closest people to us were in the space station in orbit above our heads. And yet, there was evidence of human life and waste all around us in one of the most remote parts of our planet.
So I actually trained as, surprisingly, an architect. And I was on my way to my first job as an architect in Australia from the UK, where I did my degree. And I wanted to get there without taking an aeroplane, which was a long way and had a lot of oceans in between. And I ended up hitchhiking on a boat across the Atlantic and the Pacific Ocean. And it was on that journey where I started to see the impact that plastic was having on our planet, both seeing it firsthand in the ocean and then also stopping off on these small islands and finding that they were covered in plastic as well. So I've actually got a little sample right here of microplastic. I mean, have a look at that. This is what it's all about. So these pieces, a microplastic is typically smaller than 5 millimeters, so about the size of your little fingernail. And what happens is this plastic leaves land. Unfortunately, 80% of what we find out there is actually coming out down drains and streams and rivers, and it all runs into the ocean. And then the waves and the UV rays of the sun break plastic down into these little fragments. So this is what we've been researching, these tiny pieces. And we also find things like this bottle here, which is being broken down. You can see how the sun has changed the surface of the bottle. But what you can also see on this piece are these little marks here that are actually teeth marks from a triggerfish. So what we've been finding out more recently is that both these microplastics and the bigger pieces are in fact ending up inside fish and birds like albatross, some of the beautiful seabirds, and other marine mammals like turtles and reptiles and whales and dolphins. They're all ending up with this plastic inside them. And so this is exactly what we've been investigating. What is the impact of that plastic? We know that for these animals, they often end up dying of starvation because they've got so much plastic inside them, they can't get anything else in them. Potentially for us as humans, it might be more of a toxic impact of the chemicals that are moving up the food chain. All big, important questions that scientists are trying to figure out. So this is one of the big myths of when we get out there. We've been sailing to these areas. As scientists, we call them gyres. And they're a place where, because of the ocean currents that go round and round, in the middle, there's this really calm patch where all of the plastic wants to accumulate. And so there's this one in the Pacific that, as you say, is known as the Great Pacific Garbage Patch. And what surprised me when I first got out there is that, in fact, it wasn't an island. There wasn't this huge pile of plastic that we could clean up and bring home to land and try and do something with. But instead, we found beautiful blue ocean. But then when we looked very closely, we realized that actually it was full of these fragments. And what we now know is that there's over 5 trillion fragments of these plastics in the ocean, these microplastics. And so it accumulates there. We then get our trawling devices and we take these samples so that we can look closer at really what's going on. We do find some areas where it's grouped together, sort of maybe the size of your classroom. You'll find a mass of plastic with fishing net and weed that tangles up all of these bottles and other pieces within it as well. But most of it is so small, we can't even see it. It is this one in the North Pacific.
Okay.
Yeah, so it's between Hawaii and California. It's all to do with the ocean currents. So because our planet's spinning, it creates this Coriolis effect.
Yeah.
And in the northern hemisphere, we have a clockwise rotation that happens in the North Pacific, where we're talking about, and also the North Atlantic, the one right off where I'm now living in the UK. And so between 20 and 40 degrees latitude north of the equator, that's exactly where this spot is. And the same thing happens in the southern hemisphere, but in 3 oceans, because you've got the Indian Ocean as well. So it started out because when I tested my own body for toxic chemicals that we were finding in the ocean, I wanted to know, are they getting into us? And it turned out that actually I have got toxic chemicals inside me. I'm afraid lots of us do, because they're all around us these days. But when I looked at the impact of those chemicals, I realized that lots of them affect our hormones, these important chemical messages that the brain is sending around the body, telling us what to do. And so when I looked into the impacts of those, it turns out for us girls, these hormones are particularly important when we're pregnant and also when we give birth. And so I realized it was quite a female-centered issue of these toxics in our ocean. And so I wanted to tackle it with an amazing team of women. So we get out there, as we talked about on X Expedition, it's this whole team of women. And the key of what we're trying to do is bring together people from all different backgrounds. So we have people from all over the world join these voyages. And they also have very different skill sets. So we have on board a few scientists, but we also have a filmmaker, a journalist, an artist, a teacher, a designer, a policymaker, an engineer, all sorts of people that can basically approach this problem from different directions. So we get our whole team together, and one of the first things we do is look at the place that we're starting from. So the last trip we did was sailing from Hawaii to Vancouver. So we got to the beach in Hawaii, and we found that this whole beach was covered in these pieces of microplastic as well. I've got a tiny little jar here that you can see all these different colors. These were just picked off a little beach. And then we get on board. First thing's all about safety. So a lot of these women have never been to sea before. And it's amazing because we're about to set off and sail for a month across a whole ocean. And quite often when we're heading for one of these gyres, these accumulation zones, because of where they are, the calm patch, there's often a very windy patch around them, which is what funnels the plastic there. And so when we set sail, we first have to sail usually right into this very strong wind. So we get through that period, and then we start to do our scientific work. And so some of that is observation. We're looking at what we're seeing around us, looking at the marine wildlife, but we're also then taking samples, using a trawl, collecting the samples that end up in jars like these. There's literally hundreds of them that we've collected over the years. We mark them up with the GPS coordinates on top of them. We also analyze them on the boat. So we get our microscope out and we put a piece of this under the microscope. And the first job is simply trying to work out what's plastic and what's plankton. So we have to work out the difference, and sometimes it's really tricky. And this is what makes me realize, if I can't figure out what's plastic and what's plankton under a microscope, how is a fish supposed to figure out which one's its dinner and which one is the nasty plastic? So we do a lot of work separating these. We can then also put them on a piece of equipment that tells us the type of plastic, because this is the thing about plastic. It's a word that we give to hundreds of different materials, and they all have different properties because they all do different jobs. Some plastics are stretchy, some are hard, some are clear, some are colored. This is something that makes recycling so hard, the fact that you have so many different types of plastic. But when it comes to our science, the reason we find it interesting is because if we can work out what all of these different types are, we can have a better idea of where that plastic is coming from. So we know that the fishing industry uses a certain type of plastic for their nets. We know that the food and beverage industry uses certain types of plastic for the food. So if we can better understand where it's coming from, then we have a much better chance of solving the problem and stopping the plastic getting into the ocean in the first place. Yeah, this is a big question because obviously different people and different cultures all over the world think about this issue very differently and respond differently. And one of the fascinating things I found when I was working in the Pacific, I went to Tonga and started talking in the schools there. And as some of the kids were teaching me Tongan, the local language, we realized that there wasn't actually a word for rubbish bin. And that concept of throwing something away, which to me gave me a real insight into how they think about the problem. And that it's not only the infrastructure that we need, it's not a case of just implementing a better recycling system or a better management system, but it's also how we think about these issues. And so education is key, and sharing our learning and understanding of what's happening around the world. I think reversing is a big challenge. I think what we can do is we can switch what we're doing now, and it's not too late. I think often trying to, actually extract the damage that we've done when we're thinking about the size of these pieces of plastic, how small they are, and also that so much of it sinks. The ocean's really deep, it's 5 miles deep, some of these places we've been collecting these samples, and the technology needed to get down there is enormous. And while, yes, I'm sure it's doable, at the moment, I would say let's focus our energy and effort on stopping any more plastic getting out there. And that's our biggest challenge right now. It is a big question. The place to start, though, is to think about what we call single-use plastic. So it's really easy to get completely overwhelmed when you look around your classroom or your home and think, there's plastic everywhere. How on earth do I manage this? But the key is, it's the plastic that's in your life for 10 minutes or 2 hours or a day. That's the plastic that we can easily live without. So I'm talking about things like plastic bags. That's the big one. There's really no reason to need a plastic bag at all. You can use a canvas bag, you can use your school bag, you can carry things. The next ones are plastic bottles, something we see everywhere. It's quite good that we recycle them more than plastic bags, but there's still no need for them. I carry this with me everywhere I go, which has water in it whenever I need a drink. So there's lots of ways that we can get around that. It's also much cheaper as well. We can just fill it up from a tap. Things like cups. This is my little cup. I really like drinking tea in the morning. So this is a little cup that means I can have tea on the go and I don't need to take a disposable coffee cup. There's also things like cutlery. This is the little bamboo fork that I carry in my bag with me. That means I don't need to then take cutlery if I'm out and about. And even drinking straws. Now, this is one that I'm sure everybody can really play a part. And thinking, do I actually need a straw for my drink? If you feel like you do still really need one, there are some cool glass and stainless steel straws that you can buy as well and use them again and again. So there's some first steps to start, because we need better products on the shelves that allow us to live in a plastic-free way.